Hello everyone and welcome back. It's Steph here, and I've left you guys in the dark for the past couple of weeks. So I figured it's time to give a little update on what's going on. I think in my last video I promised that I would get up a build by last weekend. That didn't happen. And I said it was going to be a content focused thing. I think early on in that week the plans changed a little. First of all, I ended up working on a new input system, or integrating Unity's new input system, so that I could get builds working on Mac. Because we did get a build running on my teammate's computer, but the input was kind of all jacked up, and I was hoping the new Unity input system would just magically fix it, and I think it did. With the added bonus of just being a much nicer system, I was planning on integrating it at some point. Anyway, but moving on from that, I had some shower thoughts about the gameplay and figured out some things that I really wanted to implement as far as the enemies and a couple different enemy types and how everything's going to kind of play together to make some really interesting engagements. So I decided to go ahead and start working on one of those enemy types just because I wanted to see something visible on the screen for once. Of course, that didn't pan out exactly too well, because as I started to add a new enemy type, and I knew this was coming, but the architecture of my code had an assumption built in that there was only like the one kind of ship that's in the game. And the root problem of this is, like, I have this ship, or like the new enemy type is called a mite, and then I'm gonna call the ships that I already have sentinels. So I've got sentinels and I've got mites, and they have a bunch of stuff that's different from each other, and that's fine. I can have a list of these guys and a list of these guys, and that's all gravy. But the problem comes in when I want to treat those things like physics objects sometimes. Like later on in the code loop, I need to update all the physics objects, their positions, and also translate that to their game object transforms. So sometimes I'm treating these things as differently, sometimes I'm treating them as a physics object, and sometimes I'm treating them as scene representations. So I kind of had to write things in a way, or find a way to structure things so that I could do that. So of course I'm not the first person to think about this stuff, so I did a whole lot of research on it, just trying to figure out what direction I wanted to go with it. What I ended up with was a kind of, it basically looks like an entity component system. It's not a fully blown generalized version. I did end up looking a whole lot at and evaluating Unity's ECS, their new tech stack that they're pushing. And while I like the entity and component parts of that, I really don't like their systems. It's just like a whole lot of glue code and a whole lot of magic happening in the black box to kind of decide when things are being done. So that's just added a whole lot of complexity onto things, and so I kind of took that and I made my own very basic implementation within my code base. So this really just boils down into a simple sim entity struct. This is basically just an integer. And it's just an ID. So every time I create a new sentinel or the player, like I give it a unique ID, and then I add a scene representation if it has one, and I have a physics representation if the entity has that, and I just store them in the dictionaries here. And you can see I have inside the ship struct, I've got a sim entity here, and inside the mite, I've got another entity there, and there's a few other things I have sim entity IDs within them. So what this allows in the end is that I have I can iterate over all of the mites and do mite things to them. Like here I've got a job that simulates all the mites, and I have a native array of mites that gets passed in, and I do things that should be done. Now at the same time elsewhere, I can just work on the physics representation or scene representation of these mites generically, so I can do that along with all of the other entities that might have those kinds of components. An example of that right here is where I'm syncing the scene rep, or the game objects in the scene with the physics representations of the objects in the physics system, right? So I'm just going through all of the entities and setting their transform position and rotation to whatever their last scene physics representation had.
Okay, so that was the challenges from last week. And if you're wondering why things have changed in the frame, it's because I did a terrible job of recording this earlier, and so I'm just going to reshoot it. The stuff in the background is just because I was cleaning. Anyway. So this week, I am dealing with a much bigger challenge, much bigger technical hurdle, and that is pathfinding. I think this is going to be the last big technical hurdle that I need to take on. Now, I've known I've needed to do this navigation stuff at some point. The AI currently is a bit lacking. It's good enough to have a little bit of engagement there, but it's definitely going to need pathfinding in the long run. But the reason why I'm choosing to do it now is because of these new enemy types that I want to do. Basically, little spider guys that are going to swarm you and attack you and try to jump on you and be cannon fodder. So I want a fairly large number of these on screen. I want like swarms of them. And currently the way I've started to implement them with just raycasts to set their height and just moving them towards the player, there's a few issues. So one is performance. Since there's so many of them, raycasting becomes a little bit expensive at that point. But the bigger issue is collision and pathing, right? I'd be okay if they didn't, find the optimal route and weren't smart enough to, find their way to you through any environment. But the real issue is, unless I put collision simulation on them, they're going to end up passing through walls and getting into all sorts of trouble. And of course, collision is going to be really expensive. Maybe I could do it, but I don't really want to simulate collision on like 1,000 of them or whatever. I want to be able to throw as many of them as I want at the game, and then just see. I want the only constraint to be design, right? Maybe it's not going to be that great to have 1,000 of them coming at you, but I want to be able to do that and then just push that number as high as I can with it still being fun. And who knows, maybe more will be better. So for all the benefits that it will bring, it's time to work on Navmeshes or pathfinding. Now, of course, Unity has a built-in Navmesh and pathfinding system, but as you might expect with older Unity APIs, it's a little limiting. It's actually very limiting, and it's potentially not the greatest performance, and it just doesn't quite allow me to do what I want to do. The approach I'm going to take is a fairly common one. You can find it on the internet if you look up flow field pathfinding. Now, I think I would be fully comfortable on my own creating a flow field implementation for a simple grid-based, like one plane kind of thing. But my map is going to be three-dimensional, and it's going to have overhanging or overlapping parts or overlapping geometry, and so I'm not quite sure how to approach that. Now, considering that and considering my wants and needs for having a regular A-star pathfinding system for the other units, I've decided to go ahead and use Recast. Recast is an open source library for doing navigation and pathfinding. This includes generating navmeshes as well as pathfinding to utilize those navmeshes. It's a really great resource, and if you've ever really researched how to create navmeshes, you've definitely come across this. Just to show you, I have the built demo from that repository, and you can kind of see here some of the different information that it lets you debug. These are kind of the intermediary steps in the process of creating this data structure of which is used for pathfinding. So this library is really great and totally gets the general pathfinding A-star kind of regular pathfinding done for me. Or at least it would if I was just going to use it. But instead, I think what I'm actually going to do is do what I did for netcode and take this source code, which is all in C++. I'm going to paste it in as C#, and I'm going to translate it and totally refactor it to my own liking and to C#. This isn't because I think the library isn't written well or I don't like the style of it. It's actually quite well done. But the real reason is that I want to understand it from the ground up. And I want to understand these underlying data structures and how it voxelizes the environment and how it uses that to create the polygon segments on it and how it tiles it together. And I basically want to know how this works from the ground up, and I want to teach myself through this source code how to make this. And I'm hoping by doing that, I'll be able to modify it in some way or extend it so that I can also make a flow field implementation with it. Admittedly, this isn't the most timely thing I could do. This isn't the most pragmatic solution, but this is kind of this has long-term benefits that I'm interested in. I'm looking forward to really understanding this stuff and being able to use it and apply it in other ways and in games going forward. I'm actually kind of really excited to learn this stuff. It's one of those big puzzle pieces that I've never been able to quite understand. Between this and the netcode, I'm starting to build a pretty great knowledge base that's going to be powerful going forward. Now, one more thing that's been going on since you last saw me, actually it was going on then too, but all this time I've been kind of worrying about money, and the longer I go on the project and the more runny, and the closer I get to having $0 in the bank account, the more stressed I've been about that. So some of my time has also gone to figuring out what the hell I'm going to do to pay the rent. Fortunately, I've come across a job opportunity and I've acquired that job. So it's a part-time gig doing some programming for for an interesting looking game project. And I can't talk about that project yet, but hopefully sometime early next year I can talk about it. But while this is going to slow down development on Shatter Valley a little bit, it's just a part-time gig, and I'm very happy to have found it, because it fits perfectly. It's the minimum amount of time I need to spend on something other than Shatter Valley to feed myself and pay the bills. But yeah, so that's where I've been at, and that's where I'm going to be, at least for the next few weeks. I'll still try to post videos roughly weekly, and I'll try to update you on what's going on. Hopefully after this hurdle has been tackled, things will really start to pick up and we'll get a lot more content-focused content. But anyway, that's all for now. Thank you very much for watching, and I'll see you in the next one. See ya.